credit.
Oh, yeah.
We had to just like do like 3 of them.
What is it? 1, 1, then it goes 1, 1, 2, 1. Yeah.
No, that was the one. That's
Have you guys ever seen this before?
Yes.
looks familiar.
What happens here is every time you go down a row, the next number is the sum of the two directly above it. So 20 is the sum of 10 and 10. 15 is the sum of 10 and 5. 6 is the sum of that, and then just put a 1 on the end. So you go 1, that would be a 7, 21, 35, 35, 21, 7, and 1.
So that's how you expand binomials?
That's how you expand binomials.
Oh,
So it does have a use.
It does have a use, because what's happening here is you go through it. This does work out to be all the combination size. Okay. What you're able to do here is by using this Pascal's triangle. Let me get the actual real the choose scenario. The first one is 0, choose 0 for the top. That's 0, choose 0. Then you have, then it goes 1, choose 0, 1, choose 1. Then it's 2, choose 0, 2, choose 1, and then 2, choose 2, and so on and so forth, as you're going all the way down the line. Next one would be 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4. 5, choose 0, 5, choose 1, so on and so forth. That's how you get all those values. Yes, ma'am?
That second row, why is the second one 1 choose? Why did that one choose 0?
For here?
Yeah.
It always starts at 1, choose 0, then it's 1, choose 1. 2, choose 0, 2, choose 1, choose 2, 2. This would be 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3, and so on and so forth. You start at 0 on the left edge, and you end up with whatever the same value is on the right edge.
Oh, so this is how you do it long.
Yeah, exactly. This is how you get the longhand versions of this. So for those of you who had a little bit of exposure to this last year, yeah, there is a reason why you do
We were talking
this.
about the triangle instead of trying to solve.
Kind of the same idea. Pascal was kind of weird. He hung out with Newton. Get that up. So what you can do with this then is you can take and expand binomials by following that same scenario and pattern. If you take a generic form of a plus b to the n, bless you. We always start with something choose 0, something choose 1, all the way down to something choose the same something. What this works out to be is this awful looking formula that actually, after you do it a few times with just numbers, extraordinarily simple, and you're going to be kind of mad that you didn't know how to do that when you did expansion of polynomials like to the 5th power a long time ago, because it's real quick. So for example, this would work out as n choose 0 times a to the n, b to the 0, plus n choose 1, a to the n minus 1, b to the 1, plus n choose 2, a to the n minus 2, b to the 2, plus dot, dot, dot. Seems legit, right? Now,
I ran out of space after.
I know, you will. Let me show you this parallel to something with raising to a power, and you're going to see how the values drop real fast.
So I
Wait, can you wait?
Yes?
I should be writing this down, but I have no clue what I'm.
Do you need a pencil?
This looks really weird, but if you parallel it with this, x plus 2 to the 4th power. That's not the world's worst thing to have to expand out. You foil it, and then you foil it again. You know, you're foiling, you're multiplying out 2 trinomials at that point. Yes, sir? I don't know. The pattern is very easy to follow once you do it. Like I said, you've never seen it written out like that before, and it works out pretty clean. So what winds up doing here is that I go to expand this out. I'm looking to get all of the coefficients. What you start with is, well, my n value is 4, so it's 4, choose 0. My a value is x, x to the 4th. My b value is 2, times 2 to the 0 power. My next term would be 4, choose 1. It's not x to the 4th now, it's x cubed. And then it's 2 to the 1st power. The first term has degrees going down. The second term has degrees going up. The next term would be 4, choose 2, x squared, 2 squared. Again, I dropped a degree on the first term, I raised a degree on the second term. What's the next one going to look like?
4c3 plus x2 to the
And then the last term, and you're right, you do run out of room here. 4, choose 4. You start with 0, and you go all the way through 4. Yes. Yeah, you go all the way through 4. Now you have x to the 0 times 2 to the 4th. If you think about it, when you're working with these binomials, if you expand that out, see how you have x plus 2 quantity to the 4th? Wouldn't your last term, if you multiplied all that out, just wind up being 2 to the 4th power? That's how you're getting that. And the first one's just x to the 1st because you don't have a leading term coefficient. So what is 4 choose 0? It's 1. So you have 1 times x to the 4th times 1. Because anything to the 0 power is 1. 4 choose 1 is 4, right? I think? Yeah. Or wait. Yes. 4 times x cubed times 2. The next one, 4 choose 2, 6. Thank you. 6 x squared times 4. 4 choose 3, 4. X. 2 cubed is 8. And then 4 choose 4 again winds up being 1, I believe. So you have 1 times 1. 2 to the 4th is 16. So simplified out, this expanded winds up equaling x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. You're going down a degree on your first term, you're going up a degree on your second term. Each individual term starts out with the total, whatever the n value was. Choose 0, choose 1, choose 2, choose 3, choose 4, and choose you. Thank you. Okay. The weirdness is if you have a negative. You just have to throw it in parentheses. Just remember, it's usually when you have like x minus 3. Just remember that b term, just to keep that in parentheses for the negative, just watch it as you're raising it to your even or your odd powers. But other than that, this is that straightforward, okay? We'll do another one. We'll do another one with addition, okay? Let's say we have x plus 3 to the 6th power. If I have x plus 3 to the 6th power, well, I have 6 choose 0, x to the 6th, 3 to the 0. What's my next one? Are we okay with that? What's the next one?
choose 2x or
Actually, reading the pattern from showed up. Yeah, I think it did much.
So you have x to the 6th. 6 choose 1 is 1, right?
6 choose 1 is 6.
Oh, 6, thank you. Plus 6 times 3, so it's 6 times 3 times x to the 5th. 6 choose 2 then would be 15. Thank you. 3 squared is 9, is x to the 4th. 6 choose 3,
20.
20. 3 cubed is 27, x to the 3rd. 6 choose 4.
15.
And then we're on our way back down now. 3 to the 4th is 81, I believe. And then it's 15, so that'll be 6 again, correct? Once you get up halfway, your numbers, the 6 choose 0 is the same thing as,
Wait, I'm weird.
no, that's supposed to be 6 choose 6. I wrote 6 choose 6, sorry. 2, 3, this is supposed to be a 4.
Same time, and that's that triangle up there.
I got lost in what I was writing there. You're going up as 6 choose 0, 6 choose 1, 6 choose 3, 6 choose 4, 6 choose 5, 6 choose 6. For some reason, I wrote 2 here. I apologize.
And then, what do you do?
The powers, remember, the first term, the powers start at whatever the end value is. 6, 5, 4, 3, 2, 1, 0. The other ones start at 0, and they go up to your end value. Yes, sir.
So would the answer be x to the 6 plus 18 to the x to the 5th plus 135 x to the 4th plus 540 x to the 3rd plus 1,215 x squared plus 243 x plus 729?
And a deep breath. Looks right. That sounds about right.
Yeah.
The numbers.
That just goes in computer every day, Jason.
Remember, the idea here is if it's 6 choose, if you, whatever, I'm sorry, if it's x plus 4 to the 6th power, this is your end value, and it starts at 0, and it goes all the way to 6 choose 6. The first term starts at 6, the second term starts at 0, and it winds up reversed at the end. That's all it is. Yes, sir.
I'm gonna have to do 1 to the 10.
Oh, that'd be awful.
Please don't.
Be
You
awfully
have to do
fun.
all of these floors.
Oh, that'd be.
We start here.
We should do that on the window.
What?
All
A
the way.
binomial expansion on the window. That would look cool. Yes, sir.
For the second to last term, I'm not doing
243. 6 choose 5. What did you get for 6 choose 5? Would love to check. 6. 3 to the 5th is how much?
243.
243 times 6 is how much? Oh, that's you. You
I
didn't-
forgot to time it by 6. Gosh.
there you go.
Okay.
So that would be.
We're right.
1458.
Thank you.
That works. I thought it would be.
Okay. Again, the weird part will be if you have a negative value,
Oh, no.
and you just might have to do some of the power-to-power stuff.
So basically every other odd would be negative. Like every
odd would be negative.
If it's a
So-
negative term,
So
It's-
x, it would be like x to the sixth minus 18 to the x to the fifth plus 135 x to the fourth. Or would it be the opposite way? Where
no, because your first term would be positive, the second term would be negative. Yes, it would be alternating that way. So why don't we try a few of these?
Maybe like one, not four. We should do like
We should just do one that has like 10.
6 choose 5, which is 6.
And that's it.
3 to the 5th power was 243. 6 times 243 was that. Why don't we try a few of these just for fun, just see how you do.
I love fun.
So this is again on page 712. This is still section 12.2. Really tight.
Then you could probably just make it.
Alright, how much time do we have left?
These are the Pascal ones, and these were those last 4 word problems. Those last 4 word problems there are, you have to decide whether it's a permutation or combination prior to doing the problem.
Oh, what?
You should be able to figure that out relatively easily. Yes, sir.
Can I go with that?
I know, can you?
Yeah, let me back.
What are you?